All right, welcome back to the fifth lesson, the last lesson for Unit 5, and we are going to be looking at the function notation today. So what exactly is a function notation? Here it says the function notation, essentially what it does is it gives a function a name, okay? It gives the function a name, and it shows the independent variable in a function, okay? So what does it look like? Here it says, for example, since 2 equals 2x plus 1 is a function, okay, we can write it as a function notation, or we can write it in function notation as f of x equals 2x plus 1. Okay, so again, to read this, you read this as f of x. Okay, so this is f of x, and it is equal to 2x plus 1. Now, what does that mean? Well, it means that the function is evaluated for any value of x, then the solution is 2x plus 1. So if you just really compare this with y equals 2x plus 1, they're essentially the same thing. So what it's saying here is that the output f of x is the y value, where the input is the x value. So here, this gives you the independent variable x, okay? And f of x is the output, which is the y value. And the input is x, f of x is the output, okay? So it's evaluated for any x, and the solution is 2x plus 1. Okay, so that's what it means. Now let's look at some examples with actual numbers here. Okay, so here it says evaluate the function f of x equals 2x plus 1 for x equal to 3. So this is telling us we are looking for the y value if x is 3. Okay, so we can write this as f of 3, okay, because it says x equal to 3, right? This is f of x. Now we're going to replace x with 3, and f of 3 is going to equal to 2 times, then here's x. Again, we're going to switch x to 3. Okay, essentially, we're just replacing all the x's with 3. So f of 3 is going to be 6 plus 1, which is 7. Now, if the question asks us to write it as a coordinate pair, so then the answer will be 3, comma 7. Again, this is the input, that is our x value, and that is the output, which is our f of x, okay, or the y value. What is output? Output, oh my gosh, cannot spell it right. Okay, output. There we go. Okay. Here's another example. It says if f of x is equal to x squared minus 2x plus 5, we're looking for f of 2. Okay, so again, this means that the independent variable is going to be replaced with 2. Okay, so you can compare this with that. The only difference is that x is being replaced with 2, and therefore what we need to do is we're going to replace every single x that we see. You can see that there's the x. Instead of writing an x, I'm going to write a 2. And again, here is the x. Instead of x, I'm going to put a 2 there instead, okay, because we're evaluating f of 2. The plus 5 is still there, okay, so that's not changed. That's not going to be changed. So 2 squared is 4, 2 times 2 is 4, and then plus 5, and therefore f of 2 equals to 5. And that is your answer, okay? You do not need to write as a coordinate pair if it doesn't ask you, okay? All right, so here are 3 practice questions for you to try. So give it a shot and check the answer in a minute or so. Okay, so this one, f of negative 4. Okay, you know what? I'll write f of negative 4. F of negative 4 should equal to, again, I see x. I'm going to put negative 4 in there instead. I see x. I'm going to put negative 4 there instead. Negative 4 cubed is negative 64. Minus negative 4 is a plus 1. And then plus 1. So the answer here is negative 59. That's what f of negative 4 is. Okay. For the second one, f of 1/2. So then in this case, we're going to put 1/2 into x instead. So 1/2 cubed minus 1/2 plus 1. 1/2 cubed is 1 out of 8 minus 1/2 plus 1. All these are fractions, so that means I need common denominator. In this case, it would be 8. And so I change everything to over 8. To go from 2 to 8, you multiply by 4. So if you multiply the denominator by 4, you got to multiply the numerator by 4. So 1 becomes a 4. And 1 is just a whole number, so you can write that as a fraction, as 8 over 8. So we have 1 minus 4 is negative 3. Negative 3 plus 8 is a 5. So f of 1/2 is just 5 out of 8. finally, for part C, we have f of t. So this simply means we are switching or replacing all the x's by t. So here, I see x, I'm going to change it to t. Okay, I see x, I'm going to change it to t. And then we have a plus 1 there. So really, it's the same thing as the original function, except that the x variable is being replaced by t. Okay, so that's the function notation. You know what it is. That's f of something. Okay, now here's the second example. It says here we have the function g of x, right? G is the name of the function, right? Earlier we talked about function notation gives the function a name, right? It gives function a name. So here, this has a name of g, right? Earlier we have the function f, right? The function is called f. In this case, the name of the function is g. So we have g of x equals to negative 3x plus 5. We're looking for g of 2. Well, this one's easy. We just did this, right? G of 2 means that we are replacing every single x with a 2. So then this is just going to be negative 6 plus 5. So g of 2 equals negative 1. No problem. Okay, we just did this. Now part B though is a little different. Okay, here it says g of x equals to 2. What does that mean? Well, I guess the question is not quite complete. It's saying g of x equal to 2. We are actually solving for x. Solve for x, okay? Because we want to figure out what the x value is so that the output gives us a 2. So what we are replacing in this case is that we're not replacing x with a 2. We are replacing the entire g of x as a 2, right? Here's the equation. Let me rewrite that here. We have g of x equals negative 3x plus 5. I am replacing this entire g of x with a 2, right? Because it says g of x equals to 2. So there is my equation. And now I can solve for x, right? Because we have one single variable now. So to solve for x, I need to isolate for x. I need to move the 5 to the left. So by subtracting 5 on both sides, 2 minus 5 is negative 3. And that equals negative 3x. Now divide both sides by negative 3 to get rid of the coefficient here. Then you end up with positive 1 as your, oops, I don't need a fraction there. X equals to 1. Okay, so that's how you find x if you know g of x. All right, so here's some similar questions here for you to practice. We know that h of x is negative 6 and g of x is 4. We are looking for x. Okay, so it shouldn't say find, it should say solve for x. Okay, so you gotta be careful. This is saying h of x, so you have to use this function, and that's g of x, so you have to use this function. Okay, so give it a try and see how it goes. Okay, for part A, you are simply replacing the entire h of x with negative 6. So negative 6 would equal to negative 1/3 x minus 8. And now again, we are solving for x, so we need to add 8 on both sides. So that becomes 2 equals negative 1/3 times x. Now, when you solve for x, you need to get rid of this coefficient. You can simply divide both sides by negative 1/3, or you can just multiply both sides by negative 3, right? So if you multiply this by negative 3, the negative 1/3 times negative 3 will cancel out. So then you end up with negative 6 equals x. Okay. Similarly, for part B, we have g of x equals to 4. So I'm replacing this entire g of x as a 4. And then we have this as our equation. Now this equation is a little difficult or more complicated to solve. But you can remember, we can rewrite 4 as a fraction. So 4 is the same thing as 4 over 1. And when you have a situation like this, when you have a fraction equals to a fraction, you can simply cross multiply, right? You can cross multiply. So you have 4, actually I'm going to do this one first. 1 times 8 is just 8 equals 4 times 9x minus 7. 4 times 9x minus 7. So essentially what we're doing here is we are getting a common denominator of 9x minus 7 and solve for the numerator. Anyways, this is cross multiplication, right? A little trick. So we have 8 equals 4 times 9x, which is 36x. 4 times negative 7, which is negative 28. solving for x by adding 28 to both sides, you get 36 equal to 36x. Divide both sides by 36, you get x equals positive 1. Okay, so that's how you do these two questions here. Hopefully you got the same answers. Now, function notation, when we substitute, right? When we substitute, the values into x, we don't actually need to put in a particular value, right? It does not have to be a numerical value. It could be algebraic expressions, like what we did here actually with f of t, right? We could actually put in a variable. So here, similarly, we can put a into f, okay? So we have f of x equals to 5x minus 2. Now we are trying to figure out what f of a is. So we are looking for f of a. Again, this means for every single x, I'm going to switch x or replace x with a instead. And therefore, f of a is going to equal to 5a minus 2. Okay, so similarly here for part B, I'll do part B, I'll let you try part C. We are substituting x with 2x plus 1 for the f function. So again, f of x is equal to 5x minus 2. Now we're looking for f of 2x plus 1. So what that means is that every time I see x, I'm not going to write x anymore. I'm going to replace x with 2x plus 1. Okay, again, I'm substituting 2x plus 1 into the x. And now I just need to simplify this. Okay, so 5 times 2x is 10x. 5 times 1 is plus 5. And we still have the minus 2 there. Therefore, collecting like terms, you should get f of 2x plus 1 equals 10x plus 3. Okay, I'll leave the last one for you to try. Okay, so we're looking for g of 2x. Okay, so again, here's g of x. Hopefully that's the one you plug it into. G of x is equal to x squared plus x. We are looking for g of a 2x. So again, this means every time you see x, you're going to replace x with 2x. I see x, so I'm going to replace that with 2x. Now we just need to expand. 2x squared is 4x squared plus 2x. And that is all we can do. And that is your answer. Okay, hopefully this is not too bad for you, just using function notations and evaluating or solving for the variable. Okay, so what we've done is in an algebraical sense, okay? Now we're going to be looking at this graphically, okay, graphically. So here it says, function notation can be used even when there is no equation relating to variables, but we do have graphs, right? For the graph of y equal to f of x to the right, we are looking for f of 3. So recall, f of 3 means that the input is 3, right? The x value is 3, and f of 3 is looking for the y value. So if we look at this graph, when x equal to 3, that's right here, the y value it produces, it looks like, okay, now this is just some random graph, okay? So we're just going to estimate. I don't think it's exactly this point, but, we'll just say close enough. This is actually negative 5. Okay, so that is the y value when x is 3, right? Again, f of 3 means what is the y value when x is 3. This means what is the y value when x equals 3. Okay, so part B means what is the y value when x equals negative 8. Well, if we go to negative 8 for the x, that's right here, the y value is this point, and the y value there is positive 3. So this equals positive 3. Okay, for the last one, this one is the opposite, right? Instead of giving us the x, again, remember this is the output, so that's the y value. So what this is saying is, what is the x value when y equals negative 3? Okay, so in this case, when y equals to negative 3, 1, 2, 3, that's right here, negative 3, we have two x values right here, actually. Okay, so they are, so x would equal to 1, right? That's this one. And this one is, if you look at the graph closely, it's not exactly 5. Okay, negative 3 is right here. This, again, we cannot know for sure because we actually don't know the function itself, right? We don't know the equation of this function. So we will just estimate. We'll say this is about 5.2. Okay, we'll say this is about 5.2. Again, it's somewhere there. We don't know exactly what it is, but we can estimate what it is. Okay, so that concludes the all the concepts that we need to learn for chapter 5. There are practice questions down here. Okay, so please make sure you do those and let me know if you have any questions. Okay, good luck.